So today we will discuss the distribution calculations feeding from both sides. First let us start with the single side, feeding from one side, and then we'll start with the both sides. Okay. So let me change this point. Okay. Feeding from one side, one and both sides. One and both sides. Feeding from one side and both sides. Okay. So we'll start with this point. Okay. Here let me take the question. A DC distributor DC distributor. So let me. Students, can you hear me very clearly? So the question will be feeding from one side. So feeding from one side, the question will be given like this: DC distributor, DC distributor of 1000 meter, 1000 meter long, and is loaded as under distance from the feeding point. Distance from the feeding point. Distance from the feeding point, which is in meters, is 250, 750, and 1000. Then load in amperes. Load in amperes is 100 amperes, 200 amperes, and 300 amperes. The resistance of each conductor is the resistance of each conductor. The resistance of each conductor is 0.025 volts per 1000 meter. Per 1000 meter, find the voltage. Find the voltage at each load point. Find the voltage at each load point. If the voltage at the feeding point A, if the voltage at the feeding point A, the voltage at the feeding point A is maintained at is maintained at 250 volts. 250 volts. Okay. Let me take the diagram here, which is given in the question. Okay. So this is the question given with the feeding, distributor feeding from one side. Distributor feeding from one side. So let us take this point as, let's take this point as A, and what are the feeding points we can take here is 1, 2, okay, 3 different load points are there. So let us take this one as B. this will be C, and this will be the D. Okay. Okay, the question here is, what is the first load point is 100 amperes, this one. The next one will be the 200 amperes. This is the load in amperes, 300 amperes. Okay. And what is the resistance given? Resistance given is the first point, 250. Here how much it is? 250 meters. What about here? Here 750 means removing this 250 first. Then what is the next we get here? 500. That is 750 minus 250. Next, what is the other point we get here? 1000. Then 250 plus 500. How much? 750. 750 means out of 1000, what is the remaining we get here? It's again 250. Okay. Here already 250 is there. So to get 750, how much we need extra? 500. So then we get 750 from the feeding point. From the feeding point. Okay. Now the question here is, okay, let me write here. First one, resistance of each distributor. First one, let me change the ink. Resistance of each distributor is equal to how much? What is the resistance given there? 0.025. 0.025, which is in ohms per meter divided by 1000 meter. Then ohms per meter. Then conductor ohms per meter. What is the value we get here? For 1 meter length, then for 1 meter length, means the resistance of the distributor for 1 meter length, for 1 meter length is equal to, so this will be ohms. Then what we get here? 1.025 ohms per 1000 for 1 meter. Okay. Distributor for 1 meter length is how much? 1.025 divided by 1000. 1.025 divided by
2.5 into 10 power minus 5, sir.
Yes. I think I have written wrong here. Maybe it is just a minute. 0.025 divided by 1000. Okay, I have mistakenly written here. It is not 1, it is 0. Okay. Let me erase this one. This is 0.025 ml. Okay. 0.025 divided by 1000 what we get here? 2.5 into, how many zeros are there? 1, 2, 3, 4 plus 2. Then I want to put here 2.5 into 10 power minus 5 ohms. Okay. The next one will be the, after that, we know the distributor has 2 wires. The DC distributor has 2 wires. So let us take the resistance between AB. What is the resistance between A and B? Okay. Now let us take here resistance between A and B. What is the resistance between A and B is denoted by what? R1, small r1. This is R1. Okay. How to find the R1? Yes, students. First, take this value. Yes. Multiply this with this value. Everybody know this. Okay. So let us take this one as 2.5 into 10 power minus 5 multiplied by how much? 250 into every DC distributor has two wires. Every DC distributor has two wires. For that reason, we have to multiply it with 2. Okay. Okay, students. So let me change the ink here into 2. Then what is the value we get here? 250 into 2.5. Yes, how much? 250 into 2.5. 625. Okay, into 2. 1250. 1250 into 10 power minus 5. 1250 into 10 power minus 5 will be 0.0125 ohms. Okay. The next one will be the resistance between A and B is completed. Next, B and C will be denoted by what? R2. Same. This multiplied with the 500. Okay. So let me write the same in 2.5 into 10 power minus 5 into what is the value we got here? Let me write with the same ink. For green it is 500 into 2. How much the value we get here? 500 into 2.5.
0.025, sir.
Yes, 500 into 2.5 into 2 into yes 0.025 0.025 ohms. So AB is done, BC is done. Next is CD. The next will be the resistance between C and D. Let us take this one as R3. R1, R3. Okay. Same multiply this one value with the 2.5 into 10 power minus 5 multiplied by what is the value we get here? Let me change the same ink. 250 into for DC distributor it is 2 wire into 2. Then what is the value you get here? 500 into 2.5. The same 0.0125. Let me write here 2.5 into sorry into 2 into 250 1250 1250 divided into 10 power minus 5 to 10 power minus 5 what we get here 0.0125 0.0125 ohms. Okay, these are the resistances R1, R2, R3. Next we will be finding the currents. Okay, what is the current flowing through the section AB is? So let me change the thing here. Current flowing through the section AB. Current flowing through section AB is what is the current flowing through the section AB is, as I said earlier, in AB section total current will be flowing here. How many loads are there? 1, 2, 3. So there are 3 currents will be flowing here. I1 plus I2 plus I3. What is the current flowing through the section BC? just only I2 plus I3. What is the current flowing through the section CD? Only I3. Hope you understood. Now here, current flowing through the section AB is I1 plus I2 plus I3. Because in the section AB there are no tappings here. Then what is the current I1 here? I1 is 100, I2 is 200, I3 is 300. 100 plus 200 plus 300. Then what is the total current here? 600 amperes. Okay. Similarly, what is the current flowing through the section? Current flowing through the section. So let me write in the next line. Current flowing through the section BC is I2 plus I3. I2 plus I3. Okay. So what is I2 value? 200 plus 300. What is total here? 500 amperes. Okay. Similarly, current flowing through the section CD is only just I3. What is the value of I3? 300 amperes. You can just see here I1, I2, I3. Okay, which is already given in the question. We are not doing anything here. Now, let us find the voltage at point B. So we have to find the voltage at point B. How to find the voltage at point B? Voltage at point B is nothing but voltage at A, voltage at A minus voltage drop across section AC. Okay. Next one. Voltage at point B. Voltage at point B. Voltage at point B is nothing but V suffix B is equal to voltage at A minus voltage across AC. Okay. That implies what is the voltage across A? What is the voltage across A, which is given in the question here, which is 250 volts, which is feeding from point A. So here it is 250 volts. At this point, what is the value here? 250 volts. So voltage at point A is how much? 250 volts minus 250 volts minus what is the voltage across AC? How to find the VAC? VAC is nothing but VA2C. How to find VAC? Apply Ohm's law. What is the total current flowing here? I1 plus I2 plus I3 into R1. Okay, sorry, I have to written here VAB. Okay, what is the current flowing here? I1 plus I2 plus I3 is the total current flowing in the branch. Yes or no? I1 plus I2 plus I3. And what is the resistance in branch AB? Is R1. Apply KVL, apply Ohm's law here. Simple. So that implies 250 minus what is the current, total current here? 600. You can see here 600. So 600 multiplied by, what is the value of R1? R1 value how much? 0.0125. 0.0125. Okay. Solve this value. 250. 250 minus 600 multiplied by, what is the value? 0.125. 0.125. What is the value you get here? 175. 175 volts is the voltage at point B. Similarly, find the voltage at point C. Voltage at point C. How to find the voltage at point C? Similarly, VC is equal to, yes or no? VC. Or else, if you want to find the VC, C is located at which point? This point. So let us take the branch of BC. Okay. So how to find? Simple logic. How to remember means VBC is nothing but VB minus VC. I want to find VC. VC is equal to what? VB minus VBC. Simple. Okay. If you are unable to find, use this logic. Okay. Then VC is equal to, VC is equal to VB minus VBC. What is the value of VB which is obtained in the above equation? 175 minus, what is the VBC? Branch currents in the BC section. What is the branch currents here? I2 plus I3 into, what is branch BC resistance? R2. Apply here. V is equal to I into R, no? Ohm's law. If I want to find the BBC means IBC into RBC. Simple logic. What is I2 plus I3? 500. So 175 minus 500 into, what is the value of R2? 0.025. Now you calculate this one. 175 minus 500. 175 minus 500 into 500 into 0.025. 162.5. 162.5. Okay. Please cross check here. Is it correct? 250 minus 600 into 0.125. 250 minus 600 into 0.025. Sorry, it is 242.5. This is wrong. Make this as a correction. 0.0125. Okay. This and this are same. Okay. So this will be here 242.5. This is wrong. Here also 242.5. 242.5. Then what we get here? 242.5. 240.5 minus minus 500 into 0.05. 230 volts. 230 volts. Similarly, voltage at point D. Okay, voltage at point D means similarly here. D is applied means apply the take the CD branch. Then similarly VC minus VCD. What is VC here? 230 minus what is this ICD into R3. What do we get here? 230 minus what is the value of ICD? It's just 300 into what is the value of this one? 0.0125. Value how much here? 230 minus 300 into 0.025. Here it is 22.5, 222.5. Okay, hope you understood.